Symmetry, odd and even functions. The graph showed on this picture is symmetrical with respect to x-axis because it has the exact same image above and below the x-axis. This graph is symmetrical with respect to y-axis because it has the exact same image to the left and to the right of the y-axis. This graph is symmetrical with respect to the origin because it has the exact same image in the first and third quadrants of the coordinate plane. A graph would still be considered to be symmetrical with respect to the origin if the identical picture was in the second and in the fourth quadrants of the coordinate plane. This graph is not symmetrical with respect to the y-axis, x-axis, or the origin because it has its own separate axis of symmetry, x equals 2. It is possible to determine what type of symmetry the graph of a function will have without actually having to graph it. Functions that are symmetrical with respect to y-axis are called even functions. Let's look at this function f of x and try to determine if this function is even without graphing it. Remember that in the case with even functions, f of negative x is equal to f of x. To check the function for evenness, replace each x in your function with negative x and see if the result is equal to your original function. Remember, this is the function we were given. To determine if it's even, we need to replace every x in this function with negative x, like so. Negative x squared will change into x squared. Negative x to the power of 4 will change into x to the power of 4. So here is the result of replacing x with negative x. If you compare this result with the original function f, you will see that this is the exact same function, meaning function f is even. Now let's talk about odd functions. Odd functions are those functions that are symmetrical with respect to the origin, and to check the equation of a function for oddness, you need to replace each x with negative x again, but the resulting function should have every single sign flipped. In other words, wherever you originally saw plus, you should have minus, and vice versa. Let's look at an example. Here is function g. Let's replace every x inside of this function with a negative x and see what result we get. Raising negative x to the power of 3 results in negative x to the power of 3. The negative x that is multiplying the negative 4 will simply turn 4 into a positive number. So this is our final result. Let's compare it with the original function g that we were given. Here is the g of x, our original function, and g of negative x, the result of replacing every x with the negative x. Remember, for the function to be odd, every sign inside of that function needs to become the opposite of what it was when x is replaced with negative x. While the sign of 3x cubed changed and the sign of 4x also changed, the sign of 1 remained the same. This means that the function is not odd.